right, here brings us to our last method, which is going to be the Huntington Mill method. And so, once again, Webster's method turned out to be problematic, so they had to go back to the drawing board. And Huntington Hill is where we ended up. So before we start this method, there is something in mathematics that I have to define. So I do want you to understand what we're doing with geometric mean, but we use geometric mean in Huntington Hill's method. So if you go into statistics, you'll learn more about this. But for this class, I just want to give you the definition so you can hopefully understand it a bit better in the context of this method. So the geometric mean is a special type of average, or, and we like to refer to it now as mean, between two numbers. And what I mean by a special type is that what we do is, I'm going to go ahead and give us numbers. So if I say 3, I don't know what goes here, and then this is going to be 12. And say I'm trying to look for that question mark, all right? And say this pattern keeps on going, actually. Well, maybe I can even recognize this pattern that I'm multiplying by 2 to get out the next thing. So maybe I would need more numbers to actually see that clearly. Well, what you would do to figure out this question mark is you multiply 3 times 12 and you take the square root. So 3 times 12 is 36, and the square root of 36 is 6. So this value is 6. What you just found, okay, is the geometric mean between 3 and 12. We are so used to using arithmetic mean. That's when you added it all up, right, and divided by the number. This is geometric. Geometric means multiplying. So 6 is your geometric mean between 3 and 12. We use this often in mathematics. One way we use it is for average growth rate in stocks. I am just giving you more bang for your buck here. This will never be tested, but just so you can kind of clearly see maybe, or better understand it maybe. I'm just giving you this extra example, but you would never have a question like this on your exam or on your homework or anything like that. So say one stock rose by 10%, and this should actually say 1 year, and declines 20% the next. I want to know the average growth rate over those 2 years. And so what you would do is, and again, this is just a little bit more information for geometric mean, is I'm going to find the geometric mean. And so what you do here is you multiply these two values together. Well, with growth, when we're talking about percentage, we talk about 1 plus, it grew 10%. So that's why it's plus 0.10. And I'm going to multiply it by the decline. Well, that's when you take what you originally had 1, but we decline, so it's minus 0.2. And what you do is you take the square root of that. So what you have here then is the square root of 1.1 times 0.8. Well, that's the square root of 0.88. And if you use your calculator, we end up getting roughly about 0.94. And again, I'm just giving you more information on geometric mean. What that's telling you is because this is less than 1, okay, if I did 1 minus 0.94, I'd get 0.06. So what that's telling me is the average decline is 6%. So I asked for a growth rate, but it's not growing, right? Because it's less than 1. Please do not get caught up in this. If I'm royally confusing you, that is not what I meant to do. The other way I could look at this is, okay, so if you have, say we started with 1.1, we found 0.94, and we found what we ended with was 0.8. So what I found is the geometric mean between these two numbers is 0.94. And then I just related it to growth rates or declines with stocks. Well, how we would use this in context of our class is Huntington Hill. We are going to do the same thing. All right, so we have to find the total population, got to find that divisor, and then we find all that quota. The difference is now we are going to cut off, and this should say decimal, to obtain the lower quota, which is called N. Now this right here is the geometric mean. So what I mean by this, okay, is say we do all this work and you get like 5.487, something like that. You would cut this off and your N would be 5. And how you find the geometric mean is the square root of 5 times 5 plus 1, so 6. So that's the square root of 30. You're going to need a calculator. And let me actually show you how to do that in your sheets. So how you can do this is you do equals. Now your square root function, I believe, is SQ. There it is, square root. And what I'll do is 5 times 6. Enter. And let's see where I went. So I get about 5.477. 5.477. So once again, just relate it to what we're finding. 5, then it would go 5.477, and then 6. This is your geometric mean between those two numbers. Now we're going to use that to determine if we should round up or down. And so let's stop there for a second and just go back to our nifty chart that we've been using this whole time. Once again, I'm just going to fill out a bunch of things we found over and over again. Our divisor is 16.24 remaining. We found all this quota before, so we get about 17.18, 9.38, 13.17, and then 5.27. All right. Now, what I'm going to start doing is I want to go ahead, get rid of these decimals. So our lower quota is 17, 9, 13, 5. So very similar to what we've been doing. The thing now is I'm going to find the geometric mean. So remember, this is our N. This is going to be the square root of N times N plus 1. So this is going to be the square root of 17 times 18. This would be the square root of 9 times 10, square root of 13 times 14, square root 5 times 6. And let's see what in the world this gives us. I'm going to go back to Google Sheets just to get us a little bit better using this. So let's just go up here. Okay. Oh, yeah, I think it will always bring me back. All right, equals, the function is square root, and that first one is 17 times 18. Enter. So I get 17.49. Let's cross out initial. We'll put it below this. We'll have enough space there. All right, I'm just going to assume you're okay with using Google Sheets to find these square roots. So this would give me 9.487. This would give me 13.490. And this is about 5.47. All right. So now, how we figure this out is if, to find the initial allocation, instead of using the typical 0.5 to round up, right, or down, that's what we used in the previous one, we'll use the geometric mean. So we're going to compare. So if the quota is as large or larger than the geometric mean, we want, so let me write that down, geometric mean, we're going to round up. If the quota is smaller than the geometric mean, we round down. Now, it won't be as easy as you're done. You might have to deal with a modified divisor again. Okay, so let's go ahead and see. I'm going to go ahead and compare. So that is saying my geometric mean is larger than my quota. Or it looks like we always compare. So if the quota is smaller, so it looks like it would be this one, right? Because it's smaller than the geometric mean, we round down. So that's telling me this guy would round to 17. Well, it's the same case here, right? Your quota is smaller than the geometric mean, so I round down, so that stays at 9. Same case here, yikes, so that rounds to 13. And then actually same case here, so that rounds to 5. So that didn't help me at all. So I have to figure out a modified divisor. And so again, I know I should go down because I'm 1 seat short. So I'm going to try 510 simply because we've already tried it. So let me go ahead and just grab all that information from before to save us time. So remember, we did 510, I believe, up here. And all of that information is listed here. So I don't want us to have to do it again. So I am going to just write that again. So let me go down here. All right, so I'm going to say my quota then. So for my quota, and let's actually give us some, so we know what we're talking about. Sylvania, then it went to Cascade, then Rock Creek, then Southeast. Okay. So again, I'm taking this from all the information from the previous one because I'm doing Sylvania's population divided by my new divisor, my modified divisor. I got 17.39. I got 9.49. I have 13.33 if I round correctly. And I get 5.34. All right. Now the nice thing is, we already found the geometric mean because we didn't, let me zoom out a little bit. We didn't, like this is still, or let me be clear. My n here is still 17, 9, 13, 5. We did all the work with those numbers, so nothing changed. So these are I'm still comparing it to this. So here, my quota is smaller than 17.4, so I'm going to round down. So that goes to 17. Now this one, let me get a different color. My quota here is more than that geometric mean. So what that's telling me is that should be rounded up. Well, I'm sorry, I'm hesitating because if I round that, that's going to be 9.49, and that's about 9.49. So I really should look at that. Let me find that number exactly again. Let's go ahead. It's 4841 divided by 510. Yeah, I'm going to hold off on that because they're so darn close. Let's go ahead and look at 13.49, compare that to 13.33. So that gets rounded down, I know that much. Now this one is really clear. 5.47 is bigger. So I'm so sorry. I just do not want to start this video over again. They take so long. So that's going to be rounded down. Forgive me. Right? Because my quota is less than. So this is clearly going to be bigger, so that should go to 10. And so if I add these all up, 7, 3, 10, 15, I get 45. Woohoo! Woo! So my modified divisor was 510. Maybe if I chose something a little bit lower, it would have been clearer. You know, like maybe if I chose like 505 or something. But I'm going to stay true and say, I'm glad that happened on the video because maybe it will help you when you're doing it on your own. And so that takes care of our last method, Huntington Hill method, and that is what is used today. Please reach out if you have any questions, and I'll see you next time.